My name is John Garrett, and this is my Tech Demo 3 for Multivariable Calculus. For our first problem, we are tasked with graphing the region between two different functions. Our lower bound function is y equals x squared plus 2z squared, so y has to be greater than or equal to this function right here. I'll be using GeoGebra, a different software. It's just easier to visualize our first two problems. But anyways, when you graph that function right here, you can see that it is the cone that is opening up along the positive y-axis right here. Our upper bound function is y equals 18 minus x squared. When we graph that, we can see that that is a parabola opening along the negative y-axis. You can see the shape that it makes right here, where we're looking at, but x has to be greater than or equal to 0 as well as described in the problem. So if we go ahead and graph that, we'll be able to see right here that all of these positive x values this is the region that we're looking at on this grid shape right here. So we don't want any of these negative x values, and you can see right here, you see the dotted lines on the grid shape. The region that we are looking at has this long straight edge right here along the y-axis. See if we can turn it a little better. There we go. So along the y-axis, we have this long straight edge, and then as you can see, we go up to the right-hand bound for the rest of our region because we don't want to go outside this region right here. And so as you can see, it's this kind of oblong shape that we get when we sketch out this first region in these dotted grid lines right here. So for our second problem, I'll go ahead and show the math for that. We're tasked with graphing the region between these two spheres of p equals square root of 2, p equals 2, and r equals 1, the cylinder r equals 1. So for the first two spheres, we're going to use the equation x squared plus y squared plus z squared is equal to p squared. And we're just going to go ahead and plug those into our two different values. So for our lower bound, square root of 2, that means that x squared plus y squared plus z squared is going to equal to. And just to prove that, we're going to replace them with p squared, as the formula states, is equal to. And that means that p squared is equal to 2, and that means that p is equal to the square root of 2. So that checks out. And the same thing for our upper bound, p has to be less than or equal to 2. We have x squared plus y squared plus z squared is equal to 4. Replace those with p squared is equal to 4. And then from that, we are going to get p equals 2. So those check out. And our cylinder, we use spherical coordinates for this system, by the way. And for our cylinder, we're going to use spherical coordinates. So r squared is equal to x squared plus y squared. And because of that, because r equals 1, that means that x squared plus y squared also equals 1. And that is our cylinder right there. It's the math worked out. So we're going to go ahead and graph our first sphere, this sphere right here, our second larger sphere, as you can see right there. Zoom out a little bit so you can see the full picture. So we have the two spheres, one inside of the other, and then we're going to go ahead and graph our cylinder, as you can see right there. And then just to better visualize, we have the shapes, but just to better visualize where this region that we're looking at, where these points intersect, we are also going to graph these two functions, right? These two inequalities. So x squared plus y squared has to be greater than or equal to 1. And then we have our second equality right there. And as you can see, if we look at this from the top down, you can really see the region we're looking at. So this is the hole cut by our cylinder right here. This is our first sphere right here, given by this equation. That's our first sphere. And this big circle is our outer sphere. So it kind of looks like a target. And the specific region that we are trying to look for is between these two spheres, but outside of this cylinder right here. So the region that we're looking at is kind of in this area. Right here is what we want to look at. This is the region bound by the functions that we are given right here. And so now we're going to switch to CalcPlot 3D, just because it's much easier to visualize. It's much easier to graph um, the surface that we need to graph right here on CalcPlot 3D. And the math isn't really too crazy for this. It's honestly just kind of like a plug and chug. So you can see T of U of V is equal to this matrix right here. And then we just use this matrix. X is the first value, Y is the second value. So because of that, that means that X must equal U plus V over 2, and Y must equal U minus V over 2 right here. And so from that, we get this shape. which is bound by the vertices that the problem gives us. So, we have 1, 0. Yes, we have 1, 0, we have 0, 1, we have 0, -1, and we have -1, 0, and that's the shape that we are looking for in this graph right here. You can see typed out right there, and just, we give the bounds. U has to be greater than or equal to -1, less than or equal to 1. Great, and so does V as well. Thank you for watching. Happy Halloween, and have a great rest of your day.